Dear friends, in this video I am going to analyze the suicides that have taken place between the year 2001 to 2012. So I got this data from the government website, so you can get any type of government or the population or the financial related data which is related to India from this website. The name of this website is data.go.in. So you can download this data to analyze. So first of all, we will import the data. So I have imported the data, so you can click on add data, and this data is also available as a data set in Kaggle, so you can search for the data and then add it. Now let me explain you the steps, like step by step, how to analyze the data. So this is a sample model which you can use to analyze any kind of data. So first of all, we are importing the necessary packages in Python. Like NumPy is used for solving linear algebra problems, pandas is used for data processing, and matplotlib is used for plotting the graphs. Seaborn is also used for plotting the graphs, and matplotlib inline is used for plotting the graphs in between the lines. So we are using the notebook, and in notebook we will be executing a command and then plotting the graph there and then. So we are importing the file, and the file is under input directory, and the name of the file is suicides in India 2001 to 12.csv. We are importing it. Just to show the data, I am just showing you 5 lines. So def.head, it is just showing me first 5 lines of the data. So if you see, it consists of 7 columns: state, year, type code, type, gender, age group, and total. So you can use a function called df.shape. So df is a data frame, and the data frame contains the data of this CSV. So shape will give you the size or the dimension of the data. So it is a table which consists of 2,37,519 rows and 7 columns. So these are the 7 columns. So here, even though I'm showing you 5 rows, there are in all more than 2 lakh rows. So you can use another function called as df.info. So using this, you can find out if there are any null values in the given fields. So if you see, there are 7 fields, and all the 7 fields contains same number of elements or cells. So we can conclude that there are no there are no null cells. And you can also find out the data type of each of the field. So object is generally used for text, and int64 is used for numbers. So you can also find out the common statistical features like count, mean, standard deviation, min, max using a single function called describe. So all that you need to do is df, the name of the data frame, dot describe. So it will give you count, mean, standard deviation, etc. But if you see, there are total 7 columns, but it is showing you the result for only 2 columns. The reason is, you can find these statistics only for the numeric fields. So if you see here, there are only 2 numeric fields, year and total. So that is the reason only 2 fields are shown here. Now if you see this table, you will find out that there is a field called as type code. So the data is organized in such a way that the same data is organized by different type codes. So the type codes can be causes, it can be related to the education background or the social profile, etc. So what we will do is, we'll segment or segregate this data based on different type codes. So let me show you how you can do this. So here what we are doing is, df is a data frame which contains all the data. Now we want to segregate or segment the information based on the type code. education status. So what we are doing is, if type code, this is the name of the column, is equal to education status, and this information is stored in the variable called edudf. So in this you will find only the type codes which has the type code as education status. So here I've just shown you the sizes of both the data frames, the original data frame df and the edudf data frame. So you will find difference in the size. So edudf is a subset of df. So edudf has more than 2 lakhs rows, and df has more than 2 lakhs rows, and edudf has 7296 rows. So this is a subset of this. So similarly, we will segment this data based on different type codes. The second type code is the causes. So causes means the causes of the suicide, the reason why the suicide is attempted. So here you can see the type. Similarly, the third type case or the type code is means adopted. So the means adopted for doing suicide. So here you will find all the data which has type code means adopted. Similarly, you can do this for the professional profile of the persons who have done the suicide, and this is the different type code in which you are segmenting the data based on the social status. So in this way, what we have done is we have segmented the df data frame, which contains all the data, into different data frames or the smaller subset data frames based on the type code. Okay, this is based on education, this is based on cause, means, and educational profile, and the social status. So here you can see again I plotted edudf.head. So here you can see this data contains only the type code education status. Now I'll start doing some processing, which I will explain you. So here in edudf contains only the type code education underscore status. So we want only 3 fields, we don't want other fields. So what we are doing is we are extracting the fields type, gender, and total, and then storing that in the same data frame, that is edudf. So edudf previously contained 7 fields, now it will contain only 3 fields, so which is evident here. So it consists of only 3 fields. So this first field which you see is the index. So it is added by default. So you can remove this index if you want by mentioning index equal to no or false. Now, so we have segmented the data based on the education status as a type code. Then we have extracted the 3 columns which we want. Now what is the next step? So in the next step, what we are doing is we are grouping the data based on the type and gender. So type is like here, since it is education type, it is primary, middle, no education, matriculate, etc. So first it is grouping on the basis of type, and second it is grouping on the basis of gender. And so you have there is a parameter called as index equal to false. So in this parameter, we don't want to use this type field as index. So if you don't use this, it will use type field as index, because we have a separate field called index. So we don't want to make this field as index. So that is the meaning of this. So what we are doing is, so here first we are grouping them, and after that grouping, so we can count or calculate the sum, but in this case we are calculating the sum, the total of the persons doing the suicide. And then what we are doing is we are sorting the values, and sorting the values based on total. Okay, and we have mentioned ascending is equal to false. So when you say ascending equal to false, it is descending. So the data is arranged in the descending order of the total. So here if you see, this is the highest total, and then it is arranged in the descending order of the total. So just to summarize, so using these 2 lines of or this 1 line of code, we are grouping the data by type, then by gender, and calculating the sum for each group, and sorting the values based on the total. So now we have this in the tabular form. Let's print it, or let's plot it in a graphical form. So these are some of the lines that we are using for printing in the graphical form. So PLT is the object or the method that we have created for plot. So PLT dot figure, fig size 12 by 6. So 12 by 6, you can consider it as 12 by 6 inches. So here if you see, number of rows are double or maybe more, and this is less. So if you want to experiment, you can experiment this. Let's make it 6. So if I run this, it will show you a different kind of graph. So I want to have an elongated, the x-axis should be more, so I can make it 12 or 20, whatever you want. So let's stick to 12 for now. So in this way you can arrange the size. Now you can use a function called as sns.barplot. So here we need to pass some parameters. The first parameter which is shown here is x equal to type. This is nothing but x label. So here you can see type, and you can mention y equal to total. This is nothing but y label, which is total, and hue equal to gender. So this is like your legend. So here if you see, the legend is shown as gender, and here if you see the data, so you need to pass the data. The data that is passed is ed sort. So ed sort is coming from here. So here we did some processing, and then we are just plotting this. And here we have mentioned palette. So palette equal to virids. So there are different palettes available. So these are nothing but color palettes. If you don't know much about it, you can simply use this one, and you can just use different palettes if you want. All that will change is the color scheme will change, nothing else. And plt.xticks, xticks is used for the axis, the x-axis, and y-ticks is used for changing the y-axis. So you are mentioning rotation equal to 45. So this is the rotation of the x label. So if you see, the x label is the inclined by 45 degrees. And this is just the layout, you can use as it is. So in this way we are plotting this data just to get a graphical view. So if you see this data, you will find that the number of persons who are doing the suicide, they are more, or the persons whose basic education is like primary, middle, or no education, they are more prone to do suicides as compared to the persons who have the higher education. So from this data we can infer that the education is also one of the factor which influences their suicide. So it is better to make them educated so that they will become more responsible, they will become more mature, so that they will not attempt suicide. So this is one of the conclusions that we can draw. Now let's proceed further, and then let's see what other inference that we can have just by analyzing the data. So here what we are doing is we are using the social DF, which we have extracted like few minutes back. So we are extracting only 3 columns, that is type, gender, and total. And again we are using the similar approach. We are grouping by type, then gender, and then calculating the sum, sorting the values by total. The rest of the thing is same. So all that you are doing is you are plotting this graph for like on the basis of their social status. So here if you see, the persons who are married are more prone to attempt suicide. So you may say that if you want to reduce the number of suicides, then you should not get married. So this is not something that I am advocating, but this is what data is saying. And this data is collected over a period of 10 or 11, I think 12 years, and the data includes more than 2 lakhs suicides. So this is what is seen here. So we will further analyze like what are the other factors that are responsible for the suicides. Now here we are doing some adjustment to the data. So we have the data. There is a column called as bankruptcy or sudden change in economic, and there is another type called as bankruptcy or sudden change in economic status. So both are same, so we are just changing that field to, or that field element to, change in economic status. This is just a minor adjustment. And you can also, like, there is the cause is mentioned as other causes, please specity. So we were changing that value to causes not known, just simplifying that. So similarly you can do that. And now you are grouping by the causes. So here the causes, so you are grouping by the causes. So different causes are the other type. So here you can see on the x-axis you have the cause of the suicide, and on the y-axis the number of people who have attempted the suicide, and in between you will find the segregation based on gender. So you will see now this is causes not known. So here there are a lot of people for whom would not have the data like why they attempted the suicide. But if you see the second biggest factor is the family problems, and the third biggest is prolonged illness, and fourth is mental illness. So here we can say that the family problems and the prolonged illness or mental illness etc. are contributing to the suicide rates. If in some way we can reduce these family problems or the illness, or if we can provide better mental and physical health, then this will reduce suicide rate. Next we are plotting the data on the basis of the profession of the persons who are attempting suicide. So you can see that in men, the persons who are doing agriculture or the farming activity, they are attempting the suicides, and in women mostly they are housewives. So we need to figure out like what is the issue and then solve that issue in order to reduce the suicide rates. Let's analyze on the basis of the causes. So for that what we can do is there is a column called as type code, and if you match with causes, so you will find all the causes why the persons have attempted the suicide, and these causes are arranged state wise. So what we are doing is by using this df type code equal to causes, we are just extracting these causes fields and storing in causes, and I've just shown you the glimpse of it. So we are just displaying the first 5 rows. Now what we are doing is we are grouping the causes based on state and age group. So first we are grouping on the basis of state, and then we are grouping on the basis of age group, and then we are calculating the sum for each groups. So this is the result. So we are just displaying the first 5 fields, and then next we are trying to plot the pivot. So these pivot, or this pivot is similar to the pivot tables in Excel. So we want to find out what is the age group which is more vulnerable to suicides. So for that what we are doing is we are using the index as age group, and the columns are state and the values are total, and we are using this function called as dot pivot. So here you can see the first 5 rows of the pivot table. Like on the left hand side you will see the age group 0 to 14, 15 to 19 and so on, and for each state you will find these numbers. So this is shown in the tabular form, but you cannot make much sense out of it. For this we will plot the graph. So you can plot this graph. So this graph is called as heat map, wherein the color coding is used based on the value intensity. So here if you see on the x-axis you have the list of states. On the y-axis you have age group, and you have asked it to create the heat map. So in heat map, based on the value, so it will categorize the value. So the minimum value is 0, the maximum value is 60,000. So it is giving some color code. So here if you see, the 0 has the value, the lightest value, that is the color, that is white, and 60,000 has the darkest value. So by this we can identify which age group is more vulnerable for suicides. So you can see from this graph, and you can see more darker cells or darker areas in the age group between 15 to 29. So we can infer from this that the age group between 15 to 29 is the most vulnerable age group, and the second vulnerable age group is 30 to 44 age group. So these people are prone to suicides. So one of the action that we can take is, maybe we need to find out what is that is causing them to suicide. Is it employment, is it family problem, or any other problem? And then we should try to avoid that problem. Now here we are again filtering the type code based on the education status. Here is a snapshot. We are just displaying the first 5 rows for the type code education status, and here we are just grouping by state and gender and sorting by total. We are calculating sum of each groups, and then ascending equal to false, that is we are displaying in the descending form. So here we have the listing like this, like total all India, total states, total all India, total states. So this does not add value here, so we want to eliminate these rows wherever you have total all India, total states, etc. Okay, so for this we will use this code. So here ST indicates state. So what we are doing is, we are getting all those values which are not equal to total states, that is this one we are trying to avoid, and is not equal to total all India, this one, and so on. So like this we are just getting rid of these rows wherein the state has this this field or this information. Now if I plot this one, the same ST, now you will not see these entries. So you will only see the actual names of the states. You will not see total, all states, etc. Now you can, okay, now we want to analyze based on the area, like, so in some state the suicides may be more, but the reason for that may be that the area is more, so more people are living, so definitely the more people may attempt suicide. So just to get a fair comparison, what we are trying to do is, we are finding we are using area as the reference, and then we are dividing by that area so that we can get the number of suicides per unit area. So that will give some fair idea about the number of suicides happening in each state, and which state has more suicides per square area or square kilometer area. So for this we need some data, that is area data, which is not available by default in the data that is given by Government of India. So like we got this data from Wikipedia. So from Wikipedia we got the area of each state. So for Maharashtra the area is this much, West Bengal the area is this much, and so on. So this is the area of each state. So what we are trying to do is, we are just creating a dictionary, and we will use this dictionary just to normalize the data that we have, just to get the number of suicides per unit area. So here you can see the listing. So Maharashtra, this is the area, and so on. So this is a dictionary. Now we are using loops to just to add the area. This column was not there before, so we want to add the area, but we want to add the area based on the state. So what we are doing is, first we are just comparing with the state. If the ST state field matches with the state, so this state is the element of the state's area, that is this. And if it matches, we are creating another field called as area and then assigning the value state's area state. So we are just assigning this area based on the state. And then when you plot this ST head, that is, we are plotting the first 5 rows, then here you can see the area is also assigned based on the state. Now the next step is we should divide this value by this area so that you can get per unit square area. So suicides per square kilometer is equal to the total divided by the area. So here we have plotted we have just displayed the same thing, st dot head, so you can get the number of suicides per unit per square kilometer. The same thing is done. Now we are just sorting the values based on the suicides per square kilometer. So the largest one is displayed here. Now we are just plotting that in a graphical form. The same whatever you have here, it is plotted in the graphical form. So you can see by gender, like what is the suicide rate per square kilometer for each of the states which are mentioned below on the x-axis. So here you can see the Puducherry, which was earlier Pondicherry, Delhi, Chandigarh have highest suicide rates per square kilometer. So then we need to try to find out like what is that is causing them or driving them to suicide, and then we can try to get rid of those problems. The next thing what we are trying to do is we are just plotting finding some information which is for all India, not specific to each of the states. So if you see the state, so there are fields like or the entries like total, all India, etc. So we are just filtering by that. So we are just filtering by total all India, and then we are using type code as education status, and then so we are extracting this information and then we are just plotting. So here you can see the state is showing total all India, it will not show the individual state, and here it will show the type code as education status. So we are using this is India overall. So India overall we are grouping by year, that is we are calculating for each year what is the total. We are just calculating the sum, that is total. So here you can see for year 2001 the total is this much, 2002 the total is this much, and so on. So this is for all India, not specific to each state. So we are just plotting the same thing here. So this is X label, Y label, and the data is coming from this data frame overall, and we are using the color palette as VDDs, and then we are just setting the title as suicides in India overall. Okay, so here you can see year by year the number of suicides are increasing for all the states, like overall. For if you consider India as a whole, then if you see the suicide rates are increasing. Now if you want to calculate what is the increase in the suicide rate over a period of say 12 years, that is from 2001 to 2012, you can use this formula. So what I have done is, so we are just picking up the value, that is overall year equal to 2012. So we are just finding what is the value of the suicides for 2012. So we are just getting the total value. Okay, and then we are assigning it to this variable. So here we get the number of suicides in 2012, that is this value. Okay, and here we are getting the number of suicides in 2001, and then we are just calculating the percentage of the difference. So the difference in suicide rate is suicides in 2012 minus suicides in 2001 into 100 divided by suicides in. Okay, so here I need to make some changes. So here I need to use the total, that is suicides in 2000. 12. Okay, two suicides in 2012. This is correct. Okay, so let me run this. So here you can get the increase in suicide rate in 10 or 12 years is 19.88, which is approximately equal to 20 years. That is what is mentioned here. I think the same graph is plotted once again, which is not required. So in this way, using this kernel, we have tried to analyze the reason for the suicide. So initially we tried to extract based on the causes of the suicide, and then we have plotted various graphs to find out like which category is more vulnerable to like attempt suicide and so on. So using data analysis, we can analyze the data, and then based on the analysis we can come to some conclusion or inference, and based on these conclusions we can take some concrete steps to reduce the suicide rate in India. Thank you for watching this video.